Hello, friends. Can you believe that 4 billion years ago, our Earth was just a lifeless ball of boiling lava? How did it transform into the vibrant planet we know today? Where did water come from? How was the moon formed? These mysteries are tied to the birth of our sun and solar system. Around 4.6 billion years ago, only darkness filled space. Within it floated a vast cloud of gas and dust, the solar nebula, primarily hydrogen and helium. For millions of years, it drifted silently, progressively across the solar system, until a massive explosion sparked the events that created our solar system and, eventually, Earth. Let's explore this incredible journey. A nearby supernova explosion sent shockwaves into the solar nebula, causing parts of it to compress and collapse inward. This formed a flat, rotating disk called the protoplanetary disk, the precursor to our solar system. Its flat shape explains why our solar system is flat today. The planets in our solar system orbit the sun on nearly the same plane. This is because at the center of the protoplanetary disk, rising pressure and temperature gave birth to a protostar. Over time, the pressure became so intense that nuclear fusion began, converting hydrogen into helium. This process, still powering the sun, marked its formation 4.6 billion years ago. The sun captured 99.8% of the nebula's mass, leaving 0.2% for planets, moons, comets, and asteroids. In the disk, dust particles collided and stuck together, forming clusters that grew over time into planetesimals, the seeds of planets. Gravity caused planetesimals to merge, forming protoplanets through a process called accretion, where particles combine under gravitational pull. Proposed by Viktor Safronov in 1969, this idea is now widely accepted and observed across the universe. Accretion, the process of particles clumping together, is observed in solar nebulae and confirmed by meteorite studies. Chondrules and ancient uranium in meteorites provide evidence of this process. Introduced by Viktor Safronov in 1969, accretion gained recognition in the 1980s. Earth formed through violent collisions during the Hadean Eon, 4.6 billion years ago, with impacts melting rocks into lava and delivering water, shaping the planet as we know it. During the Hadean Eon, comets and asteroids brought water to Earth. Microscopic crystals show liquid water existed, which evaporated, condensed, and formed Earth's water reserves. By the end of the Hadean, Earth was a molten mass. In the Archean Eon, differentiation occurred, with heavier elements sinking to form the core and lighter ones rising to form the crust, shaping Earth's structure. The Earth's core, the hottest part, reaches temperatures of up to 6,000 DEGC. Despite this heat, immense pressure keeps its iron and nickel solid. The mantle above generates heat from radioactive decay of elements like uranium and thorium. While solid today, it was once molten. The crust, Earth's outer layer, formed as lighter elements cooled, with oxygen making up 40% of its mass. Earth's layers include more than just the crust, mantle, and core. Geology identifies 5: the lithosphere, asthenosphere, mesospheric, mantle, outer core, and inner core. The lithosphere, divided into oceanic and continental crusts, consists of tectonic plates. Oceanic crust averages 100 km thick, while the continental crust can reach 280 km. This layered structure and ongoing geological processes make Earth dynamic and life-supporting. Tectonic plate boundaries often cause earthquakes and volcanoes. Beneath the lithosphere lies the asthenosphere, a weak, continuous layer that allows plate movement. Below it, in the mantle's transition zone, high-pressure minerals like olivine and ringwoodite form and occasionally surface during eruptions or meteorite impacts. The core generates Earth's magnetic field, with a liquid outer core and a solid inner core that grows 1 mm annually. The Moon formed during the Hadean Eon from a collision with Theia, a Mars-sized protoplanet. This impact also tilted Earth's axis, stabilizing the climate and creating seasons. In the Archean Eon, volcanic gases formed an atmosphere, and cooling created oceans that absorbed CO2, enabling life. Earth's unique size, position, and magnetic field make it habitable, emphasizing the importance of protecting our planet. So friends, stay tuned by liking and following our page to know all the unknown, mysterious information.